Welcome back to the deep dive. I hope you're sitting comfortably, and maybe, and I really do recommend this for today, you've got a hot cup of chai in your hand.
Oh, definitely.
Because we are taking a chai break approach to what is, I think, the loudest, most overwhelming, and, well, frankly, the most confusing topic on the planet right now.
I am ready. And honestly, a chai break is the only way to handle this topic. If we tried to do this like some university lecture, we'd both be asleep in about 10 minutes.
Exactly.
We are stripping away all the textbooks today. No complex math, no lines of code, just a conversation.
That is exactly what I wanted to hear. Because we are talking about AI, specifically large language models or, LLMs. The engine under the hood of ChatGPT, Gemini, all those tools that everyone from a university student to your uncle on the family WhatsApp group suddenly seems to be an expert on.
Right.
But here's the thing that gets me. Does anyone actually know how it works? Is it a brain? Is it some kind of magic?
It definitely feels like magic, and you see it write a poem in 5 seconds. But our mission today is to demystify that.
Yeah.
We're using a guide from NVIDIA, but we're not just going to read it. We are going to translate it into everyday life examples, things we all know, like board exams, tuition classes.
And the art of rata, I hope. Rote memorization.
Oh, we are definitely getting to rata.
I love that.
Yeah.
So let's start with the name. Large language model. It sounds so heavy, it feels like I need a PhD just to say it. What are we looking at?
Okay, let's break it down. An LLM is, at its core, just an algorithm. It's designed to recognize, summarize, and generate text. But that's a boring definition.
Very boring.
So I want you to visualize something for me. Just picture a library.
Okay, got it. Quiet, maybe a little dusty, lots of shelves.
Now imagine this isn't just your local library. This one contains almost every book, every website, every article, basically every piece of text ever written. It is massive.
Well,
that is the large language model. The data set is, for all practical purposes, the entire internet.
that is a staggering amount of reading.
It is. Now imagine we take a student, let's call him Rohan, and we lock him in this library. His one job is to read everything. He reads Shakespeare, medical journals, Bollywood gossip blogs.
User comments on YouTube.
Everything. He reads lakhs and lakhs of documents.
So Rohan is basically the smartest person on Earth.
Well, hang on. This is where I need to be really careful. Rohan has read everything about the world. But here's the catch. He's never actually seen the world.
What do you mean by that?
Think about an apple. Rohan has read thousands of descriptions. He knows the text says they're red, crunchy, sweet, and grow on trees. But he's never held an apple. He's never tasted one. He's never felt that crunch. He only knows the patterns of words that describe an apple.
Oh, okay. That's a really important distinction.
Yeah.
He knows the words, but he doesn't have the actual experience.
Precisely. He has the map, but he's never walked the territory. These models are trained to find patterns, just like a student studying for the biggest exam of their life. But they don't have senses or consciousness or feelings.
So when I'm talking to an AI, I'm basically talking to Rohan, who's in this locked room with a billion books just shouting out answers based on what he's read.
That is a very, very accurate way to visualize it. He's the ultimate armchair expert.
Okay, but reading is one thing. How does it learn to talk back? How does it learn English or Hindi? Because when I read, I'm visualizing a plot. What is the computer doing?
This brings us to the mechanics. The technical guide talks about something called tokens.
Tokens. Okay.
Let's keep it simple. Think about how a child learns to read. We don't swallow whole sentences at once, right? We break words down.
Like into syllable.
Exactly like syllables. If the model sees the word reading, it might break it into read and ing. These little pieces are the tokens. It's not seeing words. It's seeing a stream of numbers that represent these tokens.
Okay, so it chops the language up into little bricks. How does it learn how to build a house with them?
That happens during training. And this is our board exam analogy. Imagine Rohan is preparing for the ultimate board exam. But the exam isn't about history or math. It's entirely about patterns.
Patterns, like what?
The model is constantly playing a game with itself. It'll take a sentence, cover up the last word, and try to guess it. So it notices that in millions of books, when the word new appears, Delhi often comes right after it.
Ah, okay. Or after good, morning is pretty common.
Exactly. It's not thinking, oh, I should be polite. It's thinking, statistically, morning follows good 70% of the time. It's building this massive map of connections.
You know, the source guide calls this a neural network, which sounds really intimidating, like a brain.
Yeah, and that's the inspiration. But in reality, it's more like Layers of filters. Imagine Rohan isn't just reading. He's building a mental web. He connects chai to biscuit. He connects rain to umbrella. He connects exam to stress.
So he does that billions of times.
Billions and billions of times until he has a web of connections that can mimic how humans write. It's not magic. It's just math.
So it's basically the world's most intense game of fill in the blank.
That is the perfect description. It has played fill in the blank trillions of times, so now it's really, really good at it.
Okay, let's push on this because I get that. But if I ask it to write a whole email or an essay, how does it do that? Is it writing the whole thing in its head at once?
No, and this is the fascinating part. It writes one word or one token at a time. It's a next word predictor.
A next word predictor. That sounds weirdly familiar.
It should. You use a version of this every single day. Just open WhatsApp and start typing "how are."
And the little bar suggests you.
Right. Your phone is a tiny, very simple language model. It predicts the next word based on what you usually type. An LLM is just that WhatsApp suggestion bar, but on steroids.
So AI is just a superpowered WhatsApp keyboard.
At its core, yes. The NVIDIA guide uses a classic example. Mary had a little.
Lamb.
You said lamb immediately. Why? Did you stop to visualize Mary? Did you check a database?
No, of course not. It's just...
Yeah.
It's the nursery rhyme. It's the pattern.
Right. The model does the same thing. It predicts lamb because it's seen that pattern thousands of times. It doesn't know Mary. It doesn't care about the lamb. It just knows the probability.
I get it for a short sentence. But these things write long, complicated essays. How does it stay on topic? If I'm talking about a riverbank, how does it know I don't mean a money bank? A simple next word guesser would get confused.
That is the million-dollar question. And this is where the tech took a huge leap. A few years ago, AI was like that. It would forget the beginning of a sentence. But then came transformers.
Not the robots, I'm guessing.
Unfortunately, no cool robots. A transformer is basically an architecture that allows the model to pay attention. We call it the attention mechanism.
Attention mechanism. Okay, break that down for me.
Think about how you read a difficult paragraph in a textbook. Do you give every single word the same amount of focus?
No, no way. I skim over words like the and. I focus on the keywords, the big ideas.
Exactly. You pay attention to the words that carry meaning. The attention mechanism lets the model look at the entire sentence or paragraph at once and assign importance to different words.
So, back to my bank example.
If the sentence is, he went to the bank to catch a fish, the model sees bank and it also sees fish. The attention mechanism draws a huge, thick line connecting those two words.
And that connection tells it.
It tells it, aha, we are talking about a riverbank, not HDFC Bank. Because, there are no fish in HDFC Bank.
Well, not usually.
Not usually. So this lets it keep the context. It's like a spotlight that moves around, highlighting the words that matter most.
That makes sense. It's not just looking at its neighbor, it's looking at the whole neighborhood.
That's a great way to put it.
So we have Rohan, our student. He's read the whole library. He's great at predicting the next word. But I've noticed some AIs are better at specific things. There are AIs just for coding or for medical advice. How does that happen?
This is a process called fine-tuning, and this brings us to our next analogy, tuition classes.
Oh, I know all about tuition classes. The life of going from school straight to a coaching center.
Right. So the foundation model, the basic AI we've been talking about, is like a student who has finished class 10. They have good general knowledge.
Jack of all trades, master of none.
Exactly. Now, if you want that student to become a doctor, you need to send them to specialized coaching for the medical entrance exam. That is fine-tuning.
So you take the general AI and you send it to medical tuition.
Yes. You take Rohan out of the general library and you lock him in a smaller room. In this room, there are only medical textbooks, patient records, and biology papers.
And what does that do to his predictions?
It changes his probabilities. Before tuition, if you said the patient has a cadeau, Rohan might predict a nice car. After tuition, he'll predict dot fever or dot fracture.
Because he's been trained to think like a doctor.
Exactly. And you can do this for anything, legal documents, finance, or coding. The source mentions GitHub Copilot, which is just a model that went to coding tuition.
Okay, this all sounds amazing, but it leads to the big fear. Can we trust it 100%? Does Rohan ever lie?
This is the most critical part of our chat. The answer is no, you cannot trust it 100%. And yes, it lies, but, and this is important, it doesn't know it's lying.
How can you lie without knowing it?
Let's go back to our student analogies. We all knew that one guy in school, the RADA master.
Absolutely. The rote learner memorizes the textbook word for word.
But if you asked him a question that wasn't exactly from the textbook, what would he do?
He'd either freeze up or just start reciting the closest answer he memorized, even if it made no sense.
LLMs are the ultimate RADA students. They've memorized the patterns of words, but they don't have a concept of truth. They only have probability.
So if I ask it something it hasn't seen before,
It might just guess. And because it's trained to sound confident, it will guess with total authority. In the industry, we call this hallucination.
hallucination, that's a strong word.
It fits. It's making things up that sound plausible. Instead of saying, I don't know, it invents an answer to complete the pattern.
So it's confident in accuracy.
Exactly. And the source material warns about this.
Hmm.
It also says that if the internet contains wrong or biased information, the model learns that too.
And the internet can be a pretty toxic place.
So the model can learn that toxicity. If the library has bad books, the student learns bad habits.
That's a really good reality check. It's not an oracle, it's a mirror of the internet.
A funhouse mirror sometimes.
So knowing all this, that it's a super read student who sometimes hallucinates, where do we actually use this in India today?
There are some fantastic practical uses. First, summarization. This is a superpower for students. Imagine you have a 50-page history chapter to read for an exam tomorrow.
Then there, it's panic mode.
You can feed that to an LLM and say, give me the 10 most important points. It's like having a friend who reads the book for you and just gives you the notes.
That would have saved me so much time in college. What else?
Second, the language barrier. This is huge. Maybe we have brilliant ideas, but we're worried about our English grammar in an email to a boss or a client.
Right, the whole English-Vinglish problem.
Exactly. You can write your thoughts and ask the AI, rewrite this to sound professional. It's not just correcting spelling, it's rewriting the tone.
Like a free instant editor.
Precisely. And then there's search. We all use Google. The source mentions Google's BERT model, which uses these same principles.
Like,
So now, instead of just matching keywords, Google understands the meaning of your question. It moves from just searching to actually finding.
this has been such an eye-opener. It's not magic, it's not a brain, it's a very complex probability machine.
Exactly. It's a lot less intimidating when you realize it's just math trying to predict the next word.
So let's wrap this up. If we had to summarize this entire chat, what's the headline?
The headline is this. Large language models are like incredibly well-read students who have spent their lives in a library. They're great at spotting patterns and can write beautifully. But they have never seen the real world. They don't understand truth, only probability. They are the ultimate RADA students.
And that leads to your final takeaway for us.
My advice is to treat AI like a very bright, very hardworking junior assistant. It's great for a first draft. It's great for summarizing things. But you, the human, must be the senior manager.
You have to check the work.
You have to check the work. You have to verify the facts. Never just copy, paste, and hit send.
Be the teacher, not just the student.
That's the golden rule.
I love that. Well, folks, that is your deep dive on LLMs. Next time you're at a tea break and someone says ChatGPT is going to take over the world, you can tell them, relax, it's just a very advanced game of fill in the blank.
And maybe share a biscuit while you explain it.
Definitely. Thanks for listening, everyone. Go enjoy that chai. We'll catch you on the next deep dive. Goodbye.